All right, here we go.
Welcome back to the all-wheel drive 1959 El-Camino build powered by the almighty Godzilla. Honestly, this episode took a little bit because I was pulling my hair out. I mean, I was, it is a nightmare. Long story short, we have to get this episode and change all the geometry around for the front suspension. I'm gonna dive in and show you why I did it and the theory of it. This episode's not gonna be so much hee-hee ha-ha and more technical, so strap in and let's rock and roll. I can't believe I just said hee-hee ha-ha for the intro of this video. Well, we're gonna keep it now. Let's rewind the tape. Let's do a little bit of a deep dive, and I wanna show you guys what I've learned along the way. Now, I've never built an all-wheel drive car from scratch before, so I've been running into a lot of hurdles and also learning a lot of theories and principles that I would like to convey to you. Now, the mission for this car is I wanna do three things. I wanna be able to drive it day in and day out, and it has to last. I wanna go time attack with it, and I also wanna be able to drag race. I was kind of setting things up more before for drag racing, so there's a lot that I learned with making a car handle, and we're gonna start changing things up to really make this car be able to be a multifaceted multi-tool. On this episode, we're gonna dive into pro dive, anti-dive, and finding my roll center for the front of this car. That way this car doesn't turn into a slush box when we try to make it handle. And on a serious note, my friends, I just wanted to say thank you. We just hit over 10,000 subscribers on this little old YouTube channel, and I just, golly, without you guys, this wouldn't be as epic as it is. So thank you all from the bottom of my heart, and let's keep rocking. All right, so we're gonna do not a deep dive, we're gonna do a moderate jump into the waters to try to explain to you about why I'm changing some of the stuff in my front suspension. So you remember this was the old piece that I made. This was a tab and slot system that was mainly used as a fixture jig to hold in the car. By designing this, and some of you guys remember this, it was a top piece and a bottom piece in my lower joints. This allowed me to find out where my lower frame was gonna be in the car. That's great, that's how I ran those main tubes. And this upper piece was a holder for my upper control arm. Now I was gonna box all this in and make it work. I was gonna put it together. It was gonna save me a lot of time from running a tube. It kind of was like a self-leveling, self-puzzle that I just had to pop together, which was awesome. But then I ran into a problem. The way I designed this gave me real no adjustments, right? So as you notice in this piece right here, this has a ton of anti-dive in it. The power of the internet is incredible because sometimes you find some really good people to save your butt. The whole idea was I have a ton of anti-dive in this thing, and I set it up like a stock Corvette. This really is stock Corvette geometry, which I'll put up in a picture here somewhere. So as I did that, one of the guys who actually built one of the most famous all-wheel drive cars said, you do not want to run anti-dive in an all-wheel drive car. Now I was sitting there thinking of it, and I'm like, all right, well, what do you want me to run? He says, I want you to run pro dive. Now pro dive is the inclination of this front control arm tilted forward. Anti-dive puts a mechanical load on the suspension, so when the car tries to dive down, it makes it harder. It's like adding spring rate to your spring in one direction. When you tilt this forward, that pro dive is the opposite. It's soft going down, but it's harder coming up. Now, when you think about that, you say, oh, damn, well, when I brake, it's going to want to smash down, but it's not going to want to rip up. So how's that going to help? This is how we get to the next part. Some people say running anti-dive or pro dive is equivalent to sometimes running 50 to 100 pounds on the spring. Okay, so now we know that. We know that one going this way is anti-dive, the car doesn't want to squat. Now running pro dive, the car doesn't want to rip up. So to sum all this up, what I'm going to do is create an upper perch with tabs, use my adjusters here, so when I go down the road later on in life, I will be able to adjust anti-dive, pro dive, and my instant center, or my roll center as you would call it. Roll center is really an imaginary line that intersects the two plot points of your upper and lower control arm. Depending on where they hit in space is how the car will react. Higher roll center, harder for it to rock. Lower roll center, easier for it to rock. How somebody taught me was the roll center is equivalent to having a pry bar. Higher that handle to the lower that pivot point is, you have more leverage. When you shorten that arm up, you have less leverage. It's harder for you to crank over it. Now, there's also theories about people saying you need to have this roll center for this car. This really works. Again, we don't know. We don't know. We know we want it to be above the ground, but what we don't know is exactly where. So by designing this piece or these control arm mounts, I am now going to be able to change my instant center. And I'm also going to show you how much I can change it. Tracking instant centers or your roll center. How can I explain this in like 15 or 20 seconds? So theoretically what you do is you have to apply your upper control arm angle and your lower control arm angle, but you don't do it the way you think you want to do it. You do it from the middle of the ball joint to the middle of the heim joint or where the pivot point actually is, so say the middle of the bolt on the lower control arm. Once you get those two planes, you intersect them wherever they go in space. From that plot point in space, you then tie it over to the middle of the center of the wheel. So you only need a few measurements. You need the wheelbase, the width of the wheel, the width of the car, the exact angles of the upper and lower control arm, and then you plot them on, say, something like this. You're supposed to do it with a program, but I just kind of figured out how to do this to save me some money and time. As you can see here, I have multiple plot points, but the two that I came up with that were the best were the ones that I ended up running with, and that's how I got my geometry for the upper control arm height. All right, let's get to it. So now that I have some of the measurements, I know where I'm starting off from. The biggest thing is I need to start my lower control arm mount. I actually had these spindles or spacers machined at a place called Nagel Machine. All it is a lower spacer to hold my lower control arm space in the middle. I'm going to go a little overboard with this one. I'm going to create some tabs that all run together. I want my footprint on the lower tube to be as big as I possibly can. So I did 4 1/4-inch tabs, a top aesthetic bracket that will tie it all in, its tab and slot. And I'm going to go ahead and cut this out of 1/4-inch material. See if we can load this guy. Oh! Remember that crazy cross member from last episode? Once I finished it, I weighed it. It was 58 pounds. So I said, yep, I like being artistic, but not worth 58 pounds. Top plate on. Let's line these guys. Index is in. Boom. This will always be my favorite part. We're going to break out the welder, take this thing on up. So you're going to see this a lot in this episode. This laser was killer for this whole project. What I'm going to do now is laser and make 2 marks on my chassis table since I know it's straight to the body. And I'm going to project the line over so I can center both spindles perfectly in line with each other. Once I get both spindles in line with each other, I'll tack those on. I'm not going to fully weld them for this episode. I just wanted to get everything tacked, prove my theory, then I'll go back over and weld everything up. And we're going to break out the old level again. I tell you what, putting OT on in this shift. What I'm trying to do now is perfectly straighten this to the rocker panel on the car itself. Once I have that location, I'm putting in some support bars. Those two upper control arm bars are not going to be tied to these support bars, which will triangulate later on in life. But for now, they need a home. Okay, so now that we have our two upper bars, it's time to put in some sort of a support so they don't flex while I'm doing testing or while I'm actually putting the upper mounts on. So this first tube is very basic, just doing a cross tube for the lower mount. Cut that, notch that, pop that right in. Now, the fun begins here. Once I tack this in, I'm going to measure for my upper bar. This is going to be cool, a little bit more of an artistic piece, but I'm going to put two 40-degree bends in and bend this bar down. I don't know what I'm doing here, but apparently I'm measuring for the other bar. I guess I forgot the order of my own show. But as I'm tacking in those support bars again, I go right back to the thing we were just talking about. So this bar here is just going to be two 40-degree bends. I'm going to do a really aggressive swoop down, and I thought this would look kind of cool when it's done, so we'll find out. Once I measure that, I actually put a support post in the middle so I don't have to fight with it, and that support bar itself is going to hold it up while I make my two aggressive miters on the end. Now we're going to pop her right in, and this will hold itself up while I mark for my end of my miters. I have a feeling these are going to be a little aggressive, so I won't be able to actually cut them on my bandsaw, so I just chop them off with the old angle grinder. Once we get those off, I can put them back on the tube and figure out how the notch is going to be on this. And there's me again, just polishing away. Ever since I bought that thing, I've been polishing everything in sight, so I have to put that down after some time. There she is. We're back in. Now we have her height. Oh, there's the polisher again. This is cool. I got the old slider out for this shot, so it's sliding underneath me while I'm welding. But I'm tacking that top tube in, and once I have myself some structural support, she's in it. We got tubes everywhere. Just tubes flying around. Okay, we're almost in the home stretch. Remember in the beginning of the video, I showed you those Joe slugs. Those slugs are now going to go under these brackets. This is a 1/4-inch bracket that's a coupler for the 1 5/8 tube, and I'm using an 1/8-inch plate on the outside as a fascia piece. Those slugs press fit into this, and now that's how I'm going to be able to change my slugs on the fly. almost there, my friends. Just a little bit more leveling and a few more tacks and we can finally sit back and relax. What I'm going to do real quick just to test the theory is we're going to do a camber gain test. There's some parameters they told me that I don't want to go past, so just want to make sure my arc is all set. So I know this sounds like scribble scratch right here, but this is my base is number 3. I just kind of measured everything differently. So this is an inch, is number 2, that's 2 inches number 1, and the same thing down here. 2 and 1 are just an inch down, 2 inches below. I actually have the ability with this control arm to go way overboard. We can go, I think it was 3.5 inches up, 3.5 inches down, which we'll never do. We're aiming for an inch up, inch and a quarter maybe for compression, an inch and a quarter down for rebound on the max side. But we're gonna go real crazy and see what this thing's actually got for camber gain. So let's go to 1 inch above. So 89.9, so we got 0.2 degrees. 1 more inch up. So now we're at half a degree of camber gain for 2 inches on compression. And real crazy, which we'll never see, which is 3 inches. That means we'll be on our belly. We have 1 degree of camber gain of 3 inches of compression, which we would never see. It looks like a monster truck. So 1 degree total. Let's go back down to our base. So we're at 90. Let's go all the way down. 1 inch. Two inches, a little past 2 inches, we are at 0.4 degrees on rebound. So in our arc circle, we have 0.4 degrees on our rebound. And compression, we went all the way up. We have directly at 90 at ride height, which we can also adjust through here. We'll be able to give ourselves 1 or 2 degrees of camber when we go race or drive on the street. But as for camber gain, we have a total of, let's go crazy, boy, 3 inches, 1 degree. And then as for the base, say for here again, we go to just, let's go 1 1/4 for compression. That seems about right. 0.2 degrees. So I'm happy with that. I know there's a whole theory of how much actual camber gain you want, but here's the cool part of what we did up top. I would say we're on the very minimal side. We have very little camber gain, which we do want some. How much do we want? We don't know. We'll find out. But I know that if we change the instance center here and lower this plot point, we will now allow this thing to have more camber gain because we're changing the arc circle. This is now lower. And to know where the car actually wants to be, let me make this very brief. Lowering this upper plot point, lowering it down, raises your roll center. The mechanical advantage gets tighter. That's making the car tighter. Lowering this point down makes the car tight. Raising it makes it more loose. Now, as for this car, I don't really know how tight or loose I want it. Is this really something I should have worried about? I don't know, but now I know I have the ability to tighten the car up. Later on down the road, when we go racing, I can actually add tightness to the car by lowering these down, or I can add anti-dive or pro-dive. We now have the ability to go test and function all these plot points. I can also change camber curve by lowering this, and I can also add camber with these, so we have a lot more adjustments. The only thing that I'm thinking about doing later on to go overboard is I'll snip these and add some sort of a end sleeve and be able to adjust these so I can also control the height of this. So yeah, I feel like we got some ground covered now when it comes to being able to adjust the front suspension. All right, on that note, we're gonna end this episode, guys. Thank you for tuning in and being part of this amazing, I don't even know what you would call this. Is it an adventure? But before we end it, let's just give it one more. Oh, I tell you what, this thing is starting to take a life of its own. Honestly, I'm just creating piece by piece and kind of moving forward with it. I'm kind of letting the car just go where it wants. Man, this thing looks, oh, I'm proud of that one. Something incredibly scary about jumping into a project this big. It's the unknown. I don't really know what's gonna throw at me, but the coolest thing about it is I'm gonna learn. I'm gonna push myself, and when it's done, I can look at it and be like, ha, I was capable, I could do it. I'll look back at my kids one day and be like, I built that El-Camino, you know, when I had all 4 wheels working. And they can be like, what is that? Keep on liking, subscribing, doing all that good jazz, and let's just keep on building the El-Camino. Oh, and one more note. In the next episode, we are gonna measure for the rack and pinion. We're gonna start designing stuff for the pushrod suspension. And at some point, we are gonna dive into showing you how this magical all-wheel drive system is gonna work. There's a very special piece that goes in right there. On that note, I'm gonna go get some rest. I've been here for too long and I need to take a shower and get cleaned up. So yeah, the next episode, guys. Oh, it's cold out.